Try to picture a time frame of 10 to the 100th power years. The human brain simply fails. We are biologically wired to understand days, seasons, and maybe a few centuries. When we try to grasp the total lifespan of the cosmos, our mental architecture breaks down. To map a timeline that massive, we have to imagine a singular, enduring observer. Think of it as the wanderer, a nascent consciousness that wakes up during the first microseconds of existence, built to experience every distinct epoch of the universe as it unfolds. This model illustrates the universe's first fraction of a microsecond, a period called inflation. Raw vacuum energy drove an instantaneous, incomprehensible stretching of space. Space itself multiplied in scale by a factor of 10 to the 26th power in a blink. Inflation created a violent, chaotic surge of raw power. In these conditions, the extreme velocity of expansion and the intensity of the vacuum energy prevented any form of complex structure from taking hold. As the expansion slowed, the universe began to cool, triggering the Great Divide. Particles of matter and antimatter flickered into existence and immediately destroyed each other. But a tiny cosmic asymmetry existed. For every 10 billion collisions, a single particle of matter survived the annihilation. This diagram shows the next crucial step, the forge of elements. The heat dropped just enough for the strong nuclear force to take over. Disparate protons and neutrons pushed through their natural repulsion and locked together, forming the first stable atomic nuclei. By year 380,000, electrons settled into orbit around those nuclei. The primordial fog cleared, and the universe went dark. For the next 150 million years, known as the Long Night, these isolated atoms drifted through a freezing, featureless void. This shift from free-floating energy to bound nuclei provided the first stable structures in history. These atomic shields allowed matter to endure millions of years of featureless expansion, maintaining their integrity while the rest of the universe drifted toward absolute zero. Throughout that immense dark age, gravity was silently pulling those diffuse gas clouds together. The cores compressed, temperature spiked, and they finally burst into nuclear fusion. The first star scattered the darkness. We exist in the direct aftermath of that ignition, an epoch called the Stelliferous Era. Those primordial stars clustered into galaxies, serving as massive foundries. As they burned, they cooked the heavier elements: carbon, oxygen, iron, the exact materials required to form rock, water, and biological life. This is the NASA Ames Research Facility. It represents a key phase in cosmic evolution, the rise of intelligent civilizations. At this stage, the primary drive of life becomes scientific inquiry, using these stable environments to gather and process data about the universe that created them. The Stelliferous Era represents the absolute thermodynamic peak of the universe. It is a brief window where the cosmos illuminates itself, generating the precise conditions required for matter to observe its own existence. But hanging over this age is the law of entropy. It is the inescapable physical rule dictating that all structured systems, no matter how complex, will eventually break down and disperse their energy until work can no longer be performed. Tens of billions of years from now, the fading echoes epoch begins. The stars exhaust their hydrogen fuel. They collapse into white dwarfs and neutron stars, while the expanding universe pulls galaxies so far apart that they become unreachable islands in the dark. This is the Hubble Space Telescope. In a cooling universe where new stars stop forming, the opportunity for new discovery eventually vanishes. Any surviving intelligence must shift its focus toward a race to maintain and protect the data it has already managed to archive. Imagine a society realizing a permanent winter has arrived. They pull their remaining citizens closely around a few failing lamps, carefully rationing the last scraps of fuel to delay the inevitable freezing twilight. Existence in this fading universe is resistance. The conscious observer is no longer expanding into a frontier. They are struggling to hold together the memories of a cosmic tapestry that is slowly unraveling. By year 10 to the 14th, the last stellar embers burn out, initiating the black hole era. For trillions upon trillions of years, the universe is a desolate mausoleum dictated solely by extreme gravity. This 3D grid shows a supermassive black hole acting as the ultimate hoarder. Dead stars and stray signals crossing the event horizon are permanently locked away. Like mythological dragons guarding treasure, they consume the physical fabric of spacetime, locking information out of the observable universe. The universe is consuming its own physical history. Any consciousness attempting to survive here must face the absolute erasure of every physical star, planet, and record ever created. Pushed beyond 10 to the 100th years, even the supermassive black holes evaporate through Hawking radiation. The cosmos reaches heat death. A perfectly uniform void settles at absolute zero, where no further energy can ever be extracted. Stripped of the energy required to maintain biological form or machinery, the wanderer, our observing consciousness, sheds its last physical attachments. It exists as pure observation in the ultimate cosmic silence. The record of the Stelliferous Era, the birth of stars, and the rise of civilizations now exists as an internal landscape within the consciousness that witnessed it. The history of the universe is held in the memory of the observer. The journey across these 100 trillion years shows that the decline into entropy was not a failure of the systems involved. The timeline has been fully explored and its events fully recorded. In this final stillness, the value of the journey is found simply in the fact that it was witnessed from beginning to end.